Hello and welcome to another episode of 3 Minute Videos with Nathaniel. Today we will now calculate MAT Oxford 1J 2017. Tonight we will be asking the magic mirror which is the largest of these 5 integrals. The magic mirror replies, we can analyze the integrals by working out the area bounded by the graph and the x-axis and also by analyzing its maxima and minima. Let's start with A. If you calculate it, x squared minus 4 is negative from 0 to 2 and the graph will look something like this. And its minima is quite low and we know that it must not be greater than negative 4. Its absolute value must not be greater than 4. So we'll put greater than negative 4 here. So it's not a very nice one. So we'll color in the area. Obviously it's not going to be very big. So now let's calculate this. So you might know 2 plus cos x cubed is basically just 2 plus cos x. Let me draw that here. 2 plus cos x. 3, 1. This is enough from 0 to 2 pi. As you can see, it's not quite large, but now we're cubing it. 27. Then it will reach further out. Would you look at that? Its maxima is 27, which means that we are able to calculate this area. Of course we aren't. But you can see that this area is visibly larger than option A's one. Now how about C? I'm going to tell you this is not a very big integral because this is a pinhead. I mean, just look at it. Doesn't it look like a pinhead? And it also has a pinhead size area, which I'm not going to calculate for you. How about option D? I think this is going to be a big one. How about 3 minus sine x? First, let's draw the graph of 3 minus sine x on this bottom graph. 4, 3, 2. So it's from 0 to pi, and this is enough from 0 to pi. Now how about this? 729, 64. Even these values surpass option B's integral, and it looks like this. Obviously, this is not drawn to scale, but you know this is gonna be a bigger integral than C, B, let alone A. Now how about E? 108 sine cube x minus 1. So what is sine cube x minus 1? Let's draw it here. Sine cube x looks like... So let's draw sine cube x here. It looks something like this. And it's only from 0 to pi, so that means we are repeating this little figure 8 times. And now we're subtracting 1, so it now looks a little bit like this, except this is repeated times 4. And this is negative 108. You think that's going to be our outrageously large value, but no. It doesn't even surpass this 729. Although it may look fuller, it certainly isn't bigger. Now we can ask the magic mirror again because we've given some visual representations of their maxima, their minima, and some shaded areas. The magic mirror says you've done a very in-depth analysis. Let's look at the 5 graphs again. Graph A has 2 minima greater than negative 4. Graph B has a maxima at 27 and a minimum at 1, so it's quite big. C is a pinhead. D is an outrageously large area, which if one unit was this large, then it will cover almost 7.5 meters of volume, which is quite large. E, and how about this? It's a huge negative area, so don't bother about it. We are only concerned about positive integrals, not the negative ones. So in this case, A and E amount to 0. C also amounts to 0 because it's signed to the 100x. B is quite large, but D is even larger. So, the correct answer for the largest integral is option D. There you have it. Some integral analysis by drawing out some graphs and shading areas and comparing by using maxima and minima. Thank you. Bye.